Dopamine Nation. Dopamine Nation അന്നൽ എം കെയുടെ ബുക്കാണ്. It's written by Anil M.K. and I'm reading it in Kindle, and I'm reading the notes and highlights of that book, Dopamine Nation. From the highlights, from the first highlight, that is in chapter 3, the pleasure pain balance. Okay? Yeah. By better understanding the mechanisms that govern pain and pleasure, we can gain new insight into why and how too much pleasure leads to pain. Dopamine. The main functional cells of the brain are called neurons. They communicate with each other at synapses via electrical signals and neurotransmitters. Neurotransmitters are like baseballs. The pitcher is the presynaptic neuron. The catcher is the postsynaptic neuron. The pitcher is and the catcher is that is it. Okay. The space between the pitcher and the catcher is the synaptic cleft. The space between synaptic cleft. Just as the ball is thrown between pitcher and catcher, neurotransmitters bridge the distance between neurons, chemical messengers regulating electrical signals in the brain. And this is the diagram. There are many important neurotransmitters, but let's focus on dopamine. Dopamine, okay? Dopamine was first identified as a neurotransmitter in the human brain in 1957 by two scientists working independently, Arvid Carlsson and his team in Lund, Sweden, and Kathleen Montagu, based outside of London. Carlsson went on to win the Nobel Prize in Physiology or Medicine. Dopamine is not the only neurotransmitter involved in reward processing, but most neuroscientists agree it is among the most important. Dopamine may play a bigger role in the motivation to get a reward than the pleasure of the reward itself, wanting more than liking. Genetically engineered mice unable to make dopamine will not seek out food and will starve to death even when food is placed just inches from their mouth. Just inches from their mouth. Yet, if food is put directly into their mouth, they will chew and eat the food and seem to enjoy it. Debates around differences between motivation and pleasure notwithstanding, dopamine is used to measure the addictive potential of any behavior or drug. The more dopamine a drug releases in the brain's reward pathway, a brain circuit that links the ventral tegmental area and the nucleus accumbens and the prefrontal cortex, and the faster it releases dopamine, the more addictive the drug. So, dopamine reward pathways in the brain. So, here's the diagram. This is not to say that high dopamine substances literally contain dopamine. No, they do not literally contain dopamine, but they produce dopamine. Rather, they trigger the release of dopamine in our brain's reward pathway. For a rat in a box, chocolate increases the basal output of dopamine in the brain by 55 percentage. 55 percentage. Sex by 100 percentage. Nicotine by 150 percentage, and cocaine by 225%. Amphetamine, the active ingredient in the street drugs speed, ice, and shabu, as well as in medications like Adderall that are used to treat attention deficit disorder. Yeah, increases the release of dopamine by 1000%. By this accounting, one hit of a meth pipe is equal to 10 orgasms. In addition to the discovery of dopamine, neuroscientists have determined that pleasure and pain are processed in overlapping brain regions and work via an open process mechanism. Another way to say this is that pleasure and pain work in balance. Pleasure, pain. Imagine our brains contain a balance, a scale with a fulcrum in the center. When nothing is on the balance, it's level with the ground. When we experience pleasure, dopamine is released in our reward pathway and the balance tips to the side of pleasure. The more our balance tips and the faster it tips, the more pleasure we feel. But here's the important thing about the balance: it wants to remain level. It wants to remain level. It wants to remain level, that is, in equilibrium. It does not want to be tipped for very long to one side or another. It wants to remain level. Hence, every time the balance tips towards pleasure, powerful self regulating mechanisms kick into action to bring it level again. These self regulating mechanisms do not require conscious thought or an act of will, they just happen like reflex. I tend to imagine this self regulating system as little gremlins hopping on the pain side of the balance to counteract the weight on the pleasure side. The gremlins represent the work of homeostasis, the tendency of any living system to maintain physiologic equilibrium. Once the balance is level, it keeps going, tipping an equal and opposite amount to the side of pain. In the 1970s, social scientists Richard Solomon and John Corbett called this reciprocal relationship between pleasure and pain the opponent process theory. Any prolonged or repeated departures from hedonic or affective neutrality have a cost. That cost is an after reaction that is opposite in value to the stimulus. Or, as the old saying goes, what goes up must come down. As it turns out, many physiologic processes in the body are governed by similar self regulating systems. For example, John Wolfgang von Goethe, Walt Herring, and others have demonstrated how color perception is governed by an opponent process system. Looking closely at one color for a sustained period spontaneously produces an image of its opposing color in the viewer's eye. Stare at a green image against a white background for a period of time and then look away at a blank white page, and you will see how your brain creates a red after image. The perception of green gives way in succession to the perception of red. When green is turned on, red can't be, and vice versa. Thank you for watching.